So as we think about reliability, that's why the interconnection process was designed. So its core intent is important and good and should be protected. But as we increasingly step into a modern society where we have great data at our fingertips, we have fantastic compute power as a tool that we can use to help us run simulations at scale, surface new solutions to old problems and the new problems that we're not even aware are happening. These are all things we can do and apply to interconnection.
We are live here on the show floor at RE Plus Northeast in Boston. We're at the Power Up Live stage brought to you by CPS America. I'm your host, Nico Johnson, and I'm joined by the Vice President of Strategic Development at AES, Alexina Jackson. It is great to see you, Alexina.
Great to be here. Thanks so much. Good to meet you.
Likewise. AES, for many, is one of the industry giants, one of the clear leaders in development, a giant pipeline all across the United States. As such, involved in development in many, many different jurisdictions and no doubt numerous headaches with everyone's favorite topic, interconnection. So I would love to just jump right into understanding at an organizational level for a company like AES, what are some of the key challenges that you are facing in getting your projects across the finish line and to generating electrons onto the grid?
Absolutely. Certainly interconnection is a big thing we're thinking about today. I'd say probably my top challenge that I'm focused on is really the foundation of why the grid exists. That is to get energy to customers. And we're very interested in getting our customers the energy that they want. And I'm happy to say that that's increasingly renewable energy. You can imagine that interconnection is a blocker in many cases to getting that energy to our customers. You also mentioned our footprint. So because we are the number one developer for commercial and industrial customers in the US, I need to look at this challenge at a scale level. I can't be solving just one-off projects. I need to be thinking about how do we collaborate with the stakeholders in the system and find system-level solutions that includes things from technology, regulatory solutions, but also just thinking about that interconnection process that you raised at a very root cause analysis approach. What are the things that are not working about the interconnection process? Certainly, we want a process that looks to protect the reliability of the grid, right? We want that energy to get to our customers. So as we think about reliability, that's why the interconnection process was designed. So its core intent is important and good and should be protected. But as we increasingly step into a modern society where we have great data at our fingertips, we have fantastic compute power, artificial intelligence and machine learning is emerging as a tool that we can use to help us run simulations at scale, surface new solutions to old problems and the new problems that we're not even aware are happening. These are all things we can do and apply to interconnection.
For those who are maybe unfamiliar, certainly all of the developers watching are all too familiar. How does interconnection as a systemic hurdle, how does it slow projects down? And how are companies like AES working with utilities to evolve that process?
So interconnection is, as I said, that necessary first step to assessing the ability of the grid to take on new energy. By thinking through that reliability challenge, it is a long process today. We need to evaluate a number of factors, reliability, stability, the possibility of voltage issues. You can imagine already if you're not an expert in energy, you may be saying, okay, wow, this sounds complex. And in our analog system, it really is. And again, it's important, right? I don't want to underplay the importance of it. We need to get it right. And so there's a lot of care taken. That means that things that were designed to take 2 years for studies under a thermal system, because we're changing the system, we're changing the things we're connecting. We don't necessarily have the right assumptions in place, the right models in place. And so the way we study the system needs to change, but also the volume has changed dramatically, right? The amount of energy we need in the system has just burdened the process because it was built for a much slower process, much lower throughput, and analog.
Yeah, and I would say it's fair to say that most of the utilities are very cautious with the integration of renewables. As you mentioned, oftentimes thermal projects, nuclear projects, hydro projects are on a 3, 5, even 10-year build cycle, coincident with utilities, which are on a 5 and 10-year ERP cycle, resource planning cycle. And clean energy, frankly, like solar and wind, can be deployed much faster. As the industry, and I mean on the utility side, works to both slow development down to make sure that they can integrate those clean electrons, what are some solutions that you're seeing developers bring forward, like AES, that are really helping the process accelerate, but even thinking outside of the need for interconnection, perhaps?
For sure. We are looking at it, as I said, at a system level. So if you're trying to solve for interconnection, you want to think about how could I avoid interconnection or how can I make use of maybe positions I already have in unique ways, or how do I improve the process through collaboration? And I also wanted to hit on one thing that's at the back of your question, which is AES is also a utility.
Right.
So we are just fantastically positioned, and I sit in our technology part of the business. And so I am really richly positioned to be able to collaborate with our renewables team and our utilities team to find that path through. So I'm very proud to say that our AES utilities are not slowing down the process, but actually trying to lean in and say, how do we think about planning and operations in new ways? How do we deploy technologies that are really thinking about that quick path to the customer desire, right? Because we're all here, whether as a developer or as a utility, to ensure that the energy our customer needs is getting to them. And that increase in energy that I just mentioned around, needing so much more energy on the grid, we all need to be in the solution for that. And so some of the technologies we're deploying in the utility are those that are looking at how do we take existing assets and make them efficient and effective at speed so that we can actually model to the rest of the grid how it can be done. And as people see that, there's a saying that many utilities like to be first to go second. We're happy to go first and show for those who want to go second how it can be done quickly.
Yep.
And as they get the courage to do that too, obviously that helps our renewables business as well.
One of the key aspects as we begin to integrate renewable energy onto the grid is the ability for energy storage to play a role. Even a partner for AES, Fluence, which was a joint venture, is doing sort of virtual transformer or virtual transmission through batteries. Could you talk a bit about the role of the dynamic nature of clean energy generation and the tools that we employ and the flexibility of that asset as it pertains to the evolution of the grid, especially through the eyes of a developer and utility like AES?
Storage is incredibly flexible. And I think currently we're underusing that flexibility. And again, I understand why, right? We've worked in a not so digital system up until this point. And accounting for exactly what storage is doing is a key reason why we've said, okay, this is storage for energy, or this is storage as transmission. And we're limiting that flexibility of storage, right? So one of my key objectives is to really find those ways that we can let storage be its full flexible self, bring its whole self to work, so to speak, not just as a great source of renewable electrons, right? Storing it and then dispatching it again. Not just as storage as transmission, that safety net for the grid, so that if we have an unexpected loss of line, we have a great way to secure the grid, ensure its reliability while energy is redispatched, but very excitingly as well, as a way to move electrons from where they're produced in an increasingly renewable system to where they're consumed when we have that dynamic, robust energy carrying capacity or power carrying capacity on the wires. So that when the grid is congested, we already have the energy where it needs to be.
It is becoming an increasingly digital grid. And I'm curious, would you be able to speak to some of the ways that you see technology bringing this shift change to how we think about those electrons?
Yeah, I mean, there's so many things that we could talk about there. I'll give you an example of one technology that AES has been very excited about, which is dynamic line rating.
Dynamic line rating.
Yes. So it's a technology that takes static, conservative numbers that were put in place, again, to ensure that our lines were not going to be thermally overheated
Right.
or degrade too quickly. So very important reason to have these line ratings. But in history, we were using static numbers, right? Because we didn't have sensors that could sense the hour by hour, every 5 minute,
Yeah.
or even higher fidelity context for that line. So dynamic line rating can take visualization of a line, look at its line sag, can take information from the weather, look at the ambient conditions, because wind across the conductor is a great way to get more energy through the lines, and say, okay, great, we actually have dynamic visualization of line carrying capacity. Once you have that data, obviously you can not only carry more energy across the line, but now you've got information about, is my pole swaying?
Yeah.
Are trees too close? And you can make strategic decisions around tree trimming, maybe putting an inexpensive guy line up.
Yeah.
That holds and retensions that pole and gets you a better line carrying capacity. Small investments, right? But then as you apply it into a data-rich environment, apply artificial intelligence and machine learning, you start finding out what you don't know. You can fill those gaps, have better forecasts for the future, and then ultimately you can start simulating solutions, delegating decision makings where appropriate and well tested, and really step into that dynamic digital future grid that's not unlike the internet that we already use for communications.
The next step in that dynamic digital grid, as Jigar Shah said on the show back in September, is that most solar developers and solar installers, solar companies broadly, believe that they're in the solar industry, and we're really in the virtual power plant industry. Can you talk a bit about how you see through the lens of AES, virtual power plants becoming the new normal, and how that itself is a transformative technology?
So you mentioned our joint venture with Fluence. Of course, we have an investment as well in Uplight, which recently with the AutoGrid relationship is a great way to think about virtual power plants.
Okay.
But also as a utility, I mean, we very simply say, as a utility, we were the original aggregator, right?
That's a really good way to think of it.
Yeah. So we have not only that great relationship with our customer, but experience thinking about energy flows in the system, how we make sure the grid functions, how we can even think about balancing load closer to home. And so a virtual power plant, the way I think about it, is another way of solving for efficiency and obviously customer needs in our grid, but just closer to home, right? A lot of the things we were talking about earlier have to do with efficiency on the transmission system. And here we can talk about efficiency in the distribution system. And ideally in that future where we're doing efficiency measures in both, we can also break the distribution and transmission divide and talk about whole grid optimization. So a virtual power plant is a great way of creating a portfolio of assets that can be called to provide services to the customer, but also to the grid, help find that balance and enable us to build the right sized grid for our electrical future. Because one of the things we need to do is ensure an affordability in our transition to our customers.
If anyone has spent more time, well, I would argue no one has spent more time than AES on really thinking critically about the transition from the generator, from the asset owner perspective as a utility, as AES. AES has been a pioneer in clean energy, and it is so encouraging to see how AES has doubled down, not just on integrating renewables into the utility grids that you do manage, but becoming the largest C&I developer and owner-operator of assets for clean energy in the United States. It underscores the reality that the energy transition is now. It's not something that's coming. It is something that's happening now. I personally have gotten a lot smarter in this conversation. Alexina Jackson is the Vice President of Strategic Development at AES Corporation. So good to have you here. I hope that we can have you back on the show. Thank you for joining us.
Okay.
How would folks find out more about working with you or find resources that your team is putting out into the world? Where would they find you?
AES has a website, super easy, www.aes.com. We have a career page there. We have a lot of other information. You can also hit me up personally on LinkedIn.
Okay.
I make sure that I keep that up to date.
Gonna take you up on that.
Thanks.
We'll see you back on the Power Up Live stage again soon, and we'll see you back for our next interview. Thank you for joining us here live in Boston at the Power Up Live stage, brought to you by CPS America. I'm Nico Johnson, your host. We'll be back soon.